Okay, so here we are back again. All right. Hopefully you guys tried exercise 2 and 3. I'm going to skip right to these last two parts here. All right. Maybe I'll answer a few of the questions up here. So it says, explain why BEC and BFC and BDC must all be congruent. Okay. And the answer for that is because they all intersect the same arc. Okay, and this one intersects this arc here. Basically, BC is the diameter. And all three of these arcs intersect either one side of the 180 or the other. So what is their common measure? Well, if these things are 1/2 of their arc, that means that they all have to be 90 degrees. So this is going to be 90 degrees. This is 90 degrees. That is also 90 degrees. Okay, so the answer is going back to those is because they intersect the arc of the diameter. Okay, and then their common measure is 90 because their angle measure is 1/2 of the arc. So if the radius of circle A has a length of 5, okay, which means that this is going to be 5 and this is going to be 5, so it actually has a radius of 10, okay, and BD is 6 inches, find the length of DC. So we have to find this length right here. Now, hopefully it is jumping out at the seams for you, but in order to find that, we need Pythagorean's theorem, okay? We can only use this because we're talking about right triangles. So, which side length does BC signify? I'll let you think on that one for a second. Okay. So, C is the hypotenuse leg, so which means that we're just going to put 6 in for A. We'll say this side is B, and then C squared is 10 squared. So we have 36 plus B squared equals 100 minus 36. B squared is equal to 64. Square root B is equal to 8. All right, so this value right here is an 8. Okay. OC is 8. That means this is also 8. AB is 5. Okay, so again, you're just going to use the same process you did up there in order to solve that. Okay, so hopefully you guys got that one down. Now, let's get to the final pieces, okay, because this one's a little more tricky. So, the final piece we will see in this lesson regarding inscribed angles occurs when a quadrilateral is inscribed in the circle. Okay, so when I'm talking about quadrilaterals, I'm talking about rectangles, I'm talking about squares, okay, talking about rhombuses, talking about parallelograms, I'm talking about trapezoids, okay? So what does one thing that all 4 of these pieces have in common? And if you said 4 sides, 4 angles, you are correct. Okay, so that's what it means to be a quadrilateral, okay? You have 4 sides and 4 angles, okay? So these are called cyclic quadrilaterals because their ends fall on the outside of the circle. As you can see, this is a square, certainly not a rectangle, it's definitely a trapezoid, okay? So in the diagram of circle E shown, quadrilateral ABCD, okay, has been inscribed and its angles measured as shown. Okay, what is the relationship between the opposite angles in the quadrilateral? Let's add them up. see what we get. When we add up both sides, we notice that they're both 180 degrees. Okay? So that means they're opposite angles. Okay? When they add up to 180 degrees, two angle measures, they are called supplementary. Okay? They're supplementary angles. Explain why in this relationship it always hold true for quadrilaterals. Let's think about this. So this degree measure here is equal to 1/2 of this. And this degree measure here is equal to the other half of this. So if the whole circle is 360 degrees, that means that half of 360 degrees is 180, which is what the theorem calls for. So let me write that out here. So the measure of angle, I'm just going to say A plus the measure of angle C is equal to how do I want to explain this out here? So the measure of angle A plus the measure of angle C is equal to so measure of angle A is equal to 1/2 DCB, and plus the measure of angle C is equal to 1/2 of DAB. Okay? And now, so we take a look at that. The measure of angle A plus the measure of angle C is equal to, take out a 1/2, put my arc symbols in there. And if we think about this, whoops, shrink that down. Okay, DCB plus DAB is equal to the whole circle. So the measure of angle A plus the measure of angle C is equal to 1/2. We're just going to say the whole circle, so we're just going to say 360. And so now we got the measure of angle A plus the measure of angle C is equal to 180 degrees. Okay? And that is why that works out. So, take a look at that. Let that sink in. Okay. So example 5. So quadrilateral QRST is inscribed in circle W as shown below. The measure of QRST is 12 degrees, less than 3 times the measure of QTS, and the measure of RQT is equal to the measure of RST. Okay? So let's try to take in what all of that says. So the measure of QRS, so QRS, okay, this guy right here, is 12 degrees less than 3 times the measure of QTS. That angle right there. Okay, so let's just name this one QRS X. Okay, so the measure QRS is equal to, all right, so it's 12 less So minus 12, 12 less than 3 times the measure of angle, whoops, QTS. Okay? Whoops. All right. So, well, I'm sorry, I labeled the wrong place. I want to label this X. Okay, so I just substitute X in there for that. So I'm going to have the measure QRS is equal to 3X minus 12. Okay, so this is that one there. This one is 3X minus 12. Okay, so now what do I want to say? Well, what do we know about these two angle measures here? What should they add up to? Should be 180 degrees. So 4x minus 12 equals 180. Equals 48. And so x is equal to 48. So QTS is equal to 48 degrees. Okay? And this says, what is the common measure of Q, or angle RQT and RST? So we know, except for information, these two angle measures are equal. Okay, so again, because they're equal, okay, so their measures, oops, should add up to 180 degrees. Okay, and because they're equal, then we know that this must be 90 and that must be 90. Okay, and that's it for day 3. For day 2. Day 2 we kind of split up into 2 separate things because the first one was a bit long and the second one you needed some more time to kind of let things settle. So anyway, so for homework, okay, what you're going to do is you're going to do 13, 14, 15, and 16. Okay? And that's for homework. Okay? Have a good day, you guys, and I'll talk to you later.